Hello guys, welcome to my YouTube channel, Vishwaguru, a problem solver. Today's session, we are going to discuss the motion in straight line. This one video will helpful for lot of the contents which are all related and used in the motion in straight line. Okay, first, contents in this video. What are all the contents we are going to discuss in this video? Okay, first one, displacement versus distance. First, the definition of the displacement and distance. What is the difference between these two terms, displacement and distance? Whether these two terms are always same or not. These things and all we are going to discuss with a numerical example. Then the second one, we are going to discuss average velocity and average speed. Same, the definition of average velocity and average speed. Then what is the difference between these two terms? Whether these two terms are always same or not. That things we are going to discuss with a numerical example. Then instantaneous velocity and instantaneous speed. The definition of these two terms and how does this instantaneous velocity and instantaneous speed we can get from average velocity and average speed, or how these two terms will differ from the average velocity and average speed. That things we are going to discuss here. After that, average acceleration, and from that, how can you approach to the instantaneous acceleration? Okay, then equations of motion in straight line. That we know that the three equations of the motion we will discuss in the motion in straight line. So that we will discuss here. After that, the vertical motion, that is motion under gravity. It may be moving upwards or downwards, okay, or free fall. So how does the equations of motion in vertical motion or motion under the influence of gravity will vary when the particle or object moving upwards and downwards or free fall conditions. So these are all the contents we are going to discuss in this video. As I mentioned earlier, this one video will helpful to learn a lot of the concepts which are all related and will be used in motion in straight line. Okay, let's go to the first topic, displacement versus distance, with a numerical example. Okay, first of all, what is displacement and what is distance? The displacement is defined to be the change in position of an object. Like when an object or a particle is in motion, this displacement denotes the change in the position of an object. Then what is the distance? It is called the total path length traveled by that object. Okay. Then what is the difference between these two terms? That we are going to discuss with an example. Here you can see a diagram. Here in x-axis, we had taken the distances in meter. And this will be the origin, that means O, that taken as 0 meter here, where the x equal 0 meters. Towards the positive x-axis, we can consider in terms of meter or in terms of positive distance. Towards the left side, we consider as the negative distance, okay, for the displacement purpose. And arbitrarily, here we are going to consider two positions. The position Q, that is in the positive x-axis direction. This Q is at a distance 280 meters from the origin. Same, the next position P, that is 440 meters from the origin O. Okay, so here we are going to consider two cases. First case, this object, this is at the origin. Then in the case 1, this object is moved from the origin to P. Okay, that means the motion is from O to P. It's a straight line motion. Initially, the object is at origin. Then it is going to travel in positive x direction, as mentioned in the graph, to P. This is the case 1. Okay, I'm going to mention here the case 1. Okay, in the case 1, we are going to consider the motion of the car from O to P. Okay, so in this case, what is the displacement and what is the distance that we are going to discuss? First of all, what is displacement? As per the definition, it is the change in position. Here, for this case, the origin, that is the initial position, and from O, it is going to reach the position P. It means that will be the final position. We know that the displacement is the change in position, that is final position minus initial position. So we can write this as 440 minus 0. It means that the displacement for the first case, that is 440 meters. Okay. Then what is distance? Okay. As per the definition, the distance is the total path length traveled by an object. Initially, the object is at point O. Finally, it is going to reach the point or position P. So in this motion, the total distance traveled by the object is from 0 to 440 meters. So the total path length, that is also 440 meters. Okay. So here, in the case OP, it means that when the car is moving, initially it is at the position O, that is the origin. From that, it is going to move to the position P. Okay. So here we discussed what is the displacement and what is the distance. Now, the same diagram or the graph, we are going to discuss another case. It means that initially the car, that means the object, is at the origin. Then from that origin, it is going to move to the position P. Okay. After that, it returns back to Q. Okay. Have you understand? First, it is at the origin O. From O, it is going to move to P. Then it will return back, or otherwise it will move in negative x direction from P to Q. Okay. O to P, then P to Q. So in this case, here you can see xi, that is the initial position, there is no change. But here the final position, okay, the final position that will become the Q. Okay, xi is the initial position, no issue. But now the Q, that means the O is the initial position. So that is no issue, that we can take as xi. But the final position is now Q. That will be the xf. So in this case, it means that we are going to take the case 2. The object is moving from origin O to the position P. Then from the position P to Q. Okay, in the negative x direction. So for this case, what is the displacement? As per the definition, the displacement is the change in position. It means that final position minus initial position. The final position is Q, that is 280 meters, minus the initial position, that is the origin. It means that 0 meters. So the displacement is 280 meters. Then what is the distance in this case? Okay, the distance is, as per the definition, the total path length traveled by the object. So here you can see the distance. Initially, it is at the origin O. From O to P. Okay, the distance in O to P. Then it is going to move P to Q. That means 440 to 280. So the distance will be 160 meters. Okay, that means 280 to 440 or 440 to 280. That distance 440 meters, sorry, 160 meters. It means that the total distance traveled by the object is OP plus PQ. So for OP, that is 440 plus the PQ, that is 160. So the distance traveled by the object in this case, that will be 600 meters. So here you can see the distance is 600 meter, but the displacement is 280 meter for the same motion. So from this, we can understand the displacement and the distance is not necessarily to be same in all the cases. Okay. For an example, we can say another one example. That is, you just consider a motion or circular motion. Okay. An object is going to move in circular direction. Okay. Here, we consider this as the initial position. Okay, that is the initial position. From this position, an object or particle is going to move in a circular path. Then finally, it reaches here. That means Here xi and xf both are same. So for this case, if you calculated the displacement, which is equal to the change in position xf minus xi, that equal to 0. Okay, because here this is the initial position. When the particle moves in a circular path, then again reaches to the initial position, then final position also same. So here there is no change in position, but the distance, which is the path length traveled by the object or particle, which is moving in a circular motion, here that will be equal to the path length. Here the path length will be 2 pi r the distance, where r is the radius of the circular path. Okay, so the displacement and distance is not necessarily to be same always in all cases. Okay, even sometimes the displacement may be 0, like when the object is moving in a circular path, but the distance is not necessarily to be 0 or same with the displacement. Okay, so now we had discussed what is the displacement, the definition, and distance, and what is the difference between displacement and distance. With one numerical example, we'll clearly discuss. Now we are going to discuss the next topic. Okay, the next topic in this video we are going to discuss is average speed and average velocity. The definition of average speed: it is the total distance traveled by an object divided by the time interval during which the motion takes place. Okay, that means total distance traveled divided by time interval in that motion. Then what is average velocity? It is the displacement divided by the time interval in which the displacement takes place. The speed or the average speed depends upon the distance or total distance traveled in a particular time interval. At the same time, average velocity, that depends upon the displacement in that particular time interval. Okay, this also, it's not necessarily to be same. That means average speed is not necessarily to be same with average velocity. Here we know that displacement is a vector quantity, like it has the direction, but the distance, that is a scalar quantity. So the average speed, that is a scalar quantity, and average velocity, that is a vector quantity. Simply we can say speed is the scalar quantity, velocity is the vector quantity. Okay, these two definitions, like average speed and average velocity, we are going to discuss with a numerical example. Okay, it means that we are going to verify whether these two terms are always same or not. Okay, with this numerical example, like in the previous topic, displacement and distance, we consider a graph, like O is the origin here. Two positions we considered, it is same as we discussed in displacement and distance topic. One position is P, which is at 440 meters. q, that is at 280 meters from the origin in positive x direction. So here there is a car, there is an object, it is initially at origin. From origin, it is going to move towards positive x direction. Okay. So with this reference, we are going to solve this numerical. A car is moving along a straight line, say OP in the mentioned figure. It moves from O to P in 18 seconds. Okay, from O to P, it moves in 18 seconds and returns from P to Q in 6 seconds. What are the average velocity and average speed of the car in going for two cases? When you consider the motion from O to P, the second case from O to P and back to Q from P. Okay, so for these two cases, here the time intervals are given. So by using that, already we calculated or we discussed how to calculate the displacement and distance in this case, which are all needed to calculate. This displacement is needed for average velocity. The distance is needed for average speed in the previous topic. Then with respect to the time interval, we are going to calculate the average velocity and average speed of the car in these two cases. Okay. The first case is the car. It means that O to P. The car is moving from O to P. That is the first case. Okay. Then the second case is, okay, the second case is the car is moving from O to P, but again, it is going to move from P to Q. Okay, O to P, then back to Q. That is the second case. Okay, so now we are going to discuss for the first case. That means the motion is from O to P. Okay, that is the first case. So here, the average velocity and average speed, these two things we are going to calculate. So the case 1, that is the motion of the car from O to P. Okay, the motion of the car from O to P. Okay, so in this case, it takes a time interval, that is 18 seconds. It consumes a time 18 seconds to reach P from the origin O. Okay, so we know that average speed, that is average speed, that is the total distance traveled divided by the time interval. The distance traveled that we calculated in the previous case, that means in the displacement and distance, that topic, we discussed the distance, how to calculate the distance in this case. Okay, so the distance in this case is from 0 to P, that will be 440 meters divided by the time taken in this motion is 18 seconds. So we will get, when you divide, we will get 24.44 meters per second. Okay. Then what about the average velocity in this case? This equal to the displacement divided by the time taken. Okay, displacement divided by the time taken. Okay, so here you can see when the motion of the car is from O to P, then the displacement, because this will be the final position, this will be the initial position. So the change in position xf minus xf xi, that equal to 440, same as the distance, divided by 18. So for this case, we will get same value as the average speed. Okay. So in this case, we got, that means O to P. This is the initial position. This is the final position. So xf minus xf, that is 440. The time interval is 18. When you divide, we will get 24.44 meters per second. Okay. So in this case, the average speed, average velocity, we will get the same value. As in the distance and displacement, we got the same value, and time taken, we know that that is same. So both the factors are same, then average speed and average values are same here. Okay. Then what about the values in the second case that we are going to discuss? That means the case 2. First, the motion is from O to P, then back to Q. Okay. So O to P, then back to Q. That means PQ. Okay. First, average speed. It is the distance traveled divided by the time taken. In this case, we discussed already. And for this two motion, that means O to P plus P to Q, it consumes the time interval. For O to P, it requires 18 seconds. P to Q, it requires 6 seconds. So for this motion, O to P, 18 seconds, plus for PQ, 6 seconds. So the time taken in this motion, O to P plus P to Q. Okay. In case 2, that will be 24 seconds. Okay. That will be 24 seconds. So the average speed, that is the distance divided by the time taken. Here the distance we calculated in the distance and displacement topic itself. For OP, okay, that means from here to here, it is 440 meter. From P to Q, the distance will be 160. So 440 plus 160, which is equal to 600 meter, as we discussed in the previous topic. And the time taken is 24 seconds. Okay. So 600 meters divided by 24 seconds. If you divide, we will get 25 meters per second. That is the average speed. Okay. Then what about the average velocity? We know that average velocity is the displacement divided by time taken. Here, this is the initial position. We know that displacement is the change in position. The car is initially here. From here, it is going to move P. Then returns back to Q. So the final position will be Q. This we discussed already in the displacement topic, the previous topic. So here, the average velocity, final position minus initial position, change in position, that is the displacement, divided by the time interval. Okay, so that equal to The final position is 280 meters. Initial position is origin. That means 0 meters. So 280 minus 0 divided by the time interval, that is 24. When you divide, we will get 11.667 meters per second. Okay. As in the previous case or previous topic, what we had discussed in the displacement and distance. Here also, in the case 1, when the car or the object is moving from O to P, then both the values are same. That means average speed equal to average velocity. But in the second case, that is O to P and back to Q. That means from O to P, then return back to Q. Okay. So here, this will be the initial position. This will be the final position. So the speed and velocity, that values will vary. Okay. So here, as we discussed earlier, how the displacement and distance is not necessarily to be same always. The average speed and average velocity, these two terms also not necessarily to be same always. Okay. So next we are going to discuss the topic instantaneous velocity. Here we discussed average velocity and average speed. Next, instantaneous velocity and instantaneous speed. How can you get instantaneous velocity from average velocity? Same instantaneous speed from average speed. That we are going to discuss. Okay. So here, instantaneous velocity and instantaneous speed. Previous topic, the average velocity tells us how fast an object has been moving over a given time interval, but does not tell us how fast it moves at different instants of time during that interval. Okay, like simply the first we consider, I think, can you remember O to P? It takes 18 seconds. In this given time interval, how fast the object is moving, that is the average velocity we calculated. That is 24.44 meters per second. But in this 18 seconds, okay, in this 18 seconds, at t equal to 5 seconds or t equal to 6 seconds, that means at a particular instant of time, how fast the object is moving. Okay, that from the average velocity, we didn't get it. Do you understand? It means that for over a given time interval, for 18 seconds, that means in the motion O2P, from 0 to, that means 440 meters, or 0 to 18 seconds, average velocity, or at an average, the object is moving with a velocity 24.44 meters per second. But at any particular instant of time during that time interval, that means in that 18 seconds, like any instant, like t equal to 5 seconds or t equal to 6 seconds, what is the velocity? It means that how fast it is moving. That we didn't get with the average velocity. That is called as instantaneous velocity. For this, we define instantaneous velocity or simply velocity, v, at an instant t. The velocity at an instant is defined as the limit of average velocity as the time interval becomes infinitesimally small. Okay. In other words, V equal limit del t turns to 0 del x by del t. This del x by del t, we know that that is the average velocity. In the average velocity, because the del x means that will be x of minus xi, change in position with respect to the time interval. In that average velocity, we have to make, or we have to approach the time interval, okay, that infinitesimally small. It means that that has to be 0. Okay, when you make the time interval turns to 0, then the average velocity become the instantaneous velocity. So this term we can write in the differential dx divided by dt. Okay, so here an xt graph is given. In x axis, time t is taken in seconds. In y axis, the position or distance, whatever, that is taken. Or otherwise, here we are discussing for velocity, so we consider as the position. Okay, so the position is in terms of meters is mentioned. So this curve denotes the change in x or position with respect to time. Okay, so this is the curve in the xt graph. So here, if you calculate the slope of this curve in this xt graph, that will give the average velocity for any time interval. For an example, I'm going to take that first position, that is when t equal to 3. That is the initial position. At t equal to 5, what is the position? That is the final position. Okay, it means that this will be the final position, then this will be the, sorry, this will be the initial position. Okay, that means this will be the final position, this will be the initial position in this two case. Okay, that means this we are going to take as initial position, this is the final position. So the corresponding values from this we will get it approximately 7, that initial approximately 2. Okay, the time interval, this is the ti. Okay, and this one is the 5, that is the tf. Here we are considering the del t that equal to first for 2 seconds. So in this case, that means from 5 seconds, sorry, 3 seconds to 5 seconds, or between 5 seconds to 3 seconds. The change in position approximately 7 here, and for the initial position that will be 2. So the change in position or the average velocity we will take as 7 minus 2 divided by the time interval, that is 2. So it will be 5 by 2, that is 2.5 meters per second. Okay, so here this can be achieved by getting the slope of this curve. Okay, this will be x of, this will be xi. Okay, so the vertical value that denotes del x, the horizontal value that denotes the del t. Okay, so the slope of the curve xt, that will give the average velocity. Okay. So here, if you want to calculate, for an example, instantaneous velocity, okay, instantaneous velocity, simply we at instant t equal to 4 seconds. What is the value? Here you can see, if you consider a motion, that initial position is 2, final position is 5. It requires, or it takes a time 2 seconds from 3 to 5 to reach from 2 to 7. Then we can calculate the velocity del x by del t. That is the average velocity. Okay, this 2.5 meters per second. This will tell how fast, that means at what velocity it is moving that given time interval, over a time interval. That means this 2 seconds. Among these 2 seconds, how fast the object is moving or what velocity it is moving. Okay, that means from 3 to 5, that's over this time interval. Okay, from 3, 3.5, 4, 4.55 up to this time interval, it is moving with the velocity averagely at average value 2.5 meters per second. But if you need to calculate in this given time period 3 to 5, say t equal to 4 seconds, at that instant, what is the velocity? That is instantaneous velocity. For that, that means we have to make the time interval becomes infinitesimally small. That means we have to reduce the time intervals. Previously, we considered 3 to 5, the 2 seconds. Then we have to decrease. That means del t equal to 1 second. That means it will become 3.5 second to 4.5 seconds. That means with respect to the 4 second. That means from here to here, 3.5 and 4.5. Then here you can see this motion. Okay, the corresponding value here approximately we will get 5, and this one 2.5. Okay, so the x of minus xi, that will be 2.5 divided by 1. Okay, so the v, that means for this case, again we will get approximately same. Okay, because it's an approximate curve, so we will get 2.5 meters per second. Okay, then decrease the time. Again, del t equal to 0.5 seconds. That means it will become 3.75 to 4.25 seconds. Okay, 4.25 seconds. Okay, so 3.75 to 4.25. Okay, 0.5. So here, what is the position or change in position that we can calculate? Like that, if you decrease the del t, that means the time interval infinitesimally small, then the del t approaches to 0. Then that velocity, that called as instantaneous velocity at that time t equal to 4 seconds. Okay, when the del t turns to 0, here we won't get the slope. Okay, that means we will get only the tangent. The slope means that will be the tangent to the curve in the xt graph. Okay, so like that, the average velocity means in this period of time, at an average value how fast it is moving. But the instantaneous velocity means in this given time period, at any particular instant, like t equal to 4, t equal to 3.75 or 4.25, okay, at any instant, what is the velocity? That is called as instantaneous velocity. Okay, the same way, the instantaneous speed or simply speed is the magnitude of the velocity. Okay, because the velocity means we will mention whether it is a plus or minus. Okay, like at what direction it is. Okay, but the instantaneous speed means only it is a magnitude. We won't consider the direction. Okay, for an example, if a velocity of plus 24 meter second power minus 1 and velocity of minus 24 meter second power minus 1 both have associated speed, that is 24 meter second power minus 1. Okay, that means regardless of the direction, we will mention only the magnitude of the velocity for the instantaneous speed. This also we can say for a over of time period. What is the average value of speed? That is the average speed at any instant, particular instant, when the time interval approaches to 0. Okay, here infinitesimally small means we consider approaches to 0. Then at that instant, what is the value? That is the instantaneous speed. That is the magnitude of the velocity at that instant. Okay, so then we are going to discuss the next topic, average acceleration and instantaneous acceleration. The average acceleration, to make the difference between average and instantaneous, here the average acceleration is mentioned as a bar. Over a time interval is defined as the change of velocity divided by the time interval. Okay, like velocity is the change in position with respect to the time interval. Average acceleration, that is the change in velocity with respect to the time interval. That is v2 minus v1 divided by del t. That we can mention as del v divided by del t. Change in velocity with respect to the time interval. Here v2 and v1 are the instantaneous velocities or simply velocities at time t2 and t1. It is the average change of velocity per unit time. The SI unit of acceleration for velocity, we know that meter per second, then divided by again for time interval second. So we will get meter per second square or meter second power minus 2. The same way as we discussed in the how to approach instantaneous velocity from average velocity, like the time interval approaches to infinitesimally small, that means del t turns to 0. Same way, instantaneous acceleration, that is can be defined in the same way as the instantaneous velocity, that is a equal limit del t turns to 0. In that average velocity means average acceleration. In that average acceleration, as we mentioned earlier, this will give the value in a given period of time. How the acceleration, what is the acceleration in the over a period of time? Okay, but at any instant, what is the value of acceleration? For that, we got to substitute del t turns to 0 in the at average acceleration. Then we will get dv by dt. That is the acceleration or instantaneous acceleration. Okay. Same way, average acceleration is that average value in that given time interval. But the instantaneous acceleration is at that particular instant, what is the value of acceleration when the time interval approaches to 0. Okay. So this is average acceleration and instantaneous acceleration. Simply we can say the rate of change of velocity. Okay. That instantaneous acceleration we can say rate of change of velocity. Okay. Then we are going to discuss the next topic, equations of motion. This is in straight line motion. In the numericals related in the motion in straight line, we will discuss these three equations of motion. V equal u plus at, s equal ut plus of at square, v square equal u square plus 2as, where t is the time in seconds, s is the displacement in meters, u, that is initial velocity in meters per second, v, final velocity in meters per second, a is the acceleration in meter per second square. Okay. These three equations will be used when the motion of a particle or an object in a straight line. Then motion under gravity. Here, motion of a particle or an object under the influence of gravity. So here there are two possibilities are there. Whether the object will move in upwards direction against the gravity, or along the direction of the gravity, or under the influence of the gravity, it may be a free fall motion in downward direction. So first, for free fall motion in downward direction, here in the free fall motion, or the object which is falling down under the influence of gravity, it will move along the direction of the gravity. So the changes from the previous equations of motion, what we are going to do here, instead of the acceleration or linear acceleration, it is moving with the under the influence of gravity. So the a is replaced with g. Okay. Then to define the vertical distance, we put another term h, that is height, instead of s. Okay. So a, the linear acceleration, is replaced with plus g, because along the direction of the gravity the object is going to move. Then s is going to be replaced with the vertical distance or height, the term h. So the equations are v equal u plus gt, h equal ut plus of gt square, v square equal u square plus 2gh. As usual, the other terms are already we discussed. Here the changes, h is height or vertical distance in meters. G, that is the acceleration due to gravity, which is mentioned in meters per second squared. And in Earth at sea level, we can take the value G, that is 9.81 meters per second square. Even though the value of G, that is acceleration due to gravity, that will vary with respect to the altitude, or that means from the equator, if you are moving towards the poles, okay, polar polar directions. So that values will vary, but even though it is going to vary, we are going to consider in the numericals, it is 9.81 meter per second square as a constant value. Okay. Then object thrown upwards against the gravity. That's why instead of the linear acceleration A, we are going to mention minus G because it will be against the gravity. Same, the linear distance will be replaced with a height or vertical distance h. So then the equations will be V equal U minus GT, H equal UT minus of GT square, V square equal U square minus 2GH. Okay. So these are all the terms or equations, important equations, which we will use in the numericals. This is for straight line motion. This for motion under the influence of gravity. Along the direction of gravity or free fall motion, against the direction of gravity, or when the object is thrown upwards with some initial velocity. Okay. Then the points to be remembered while solving the numerical. That means the keywords, such as here, first we are going to discuss the motion in straight line. Okay, motion in straight line. Okay. When it is mentioned as starts from rest, then its initial velocity equal to 0. Comes to rest or being stopped, okay, then its final velocity equal to 0. If it is mentioned as constant velocity, okay, then its acceleration equal to 0. These two, okay. For constant velocity, I'm going to take the first equation of motion. V equal to U plus AT. Here, if V equal to U, okay, then we know that V minus U, that equal to AT. So we can write acceleration that equal to V minus U divided by T. If the velocity is constant, that means when V equal to U, then the above term, the numerator will be 0. Okay, so we can say that acceleration is also 0. Okay, so these are all the important terms we have to remember while solving the numerical in motion in straight line. If it is mentioned as start from rest, or when the object is initially rest like that, so that initial velocity is 0. If it is mentioned as comes to rest or being stopped or ends like that, then final velocity is 0. If it is mentioned as constant velocity, then its acceleration is 0. We know that V equal U plus AT, so V minus U equal to AT. That is the first equation of motion. So acceleration equal to V minus U by T. If velocity constant, then V equal to U. Initial velocity equal final velocity. Then this term will become 0, so that acceleration equal to 0. Then the next one, that means when the object thrown upwards, okay, that means moving upwards with some initial velocity. Okay, you just consider a vertical motion of an object. Okay, just consider a vertical motion in upward direction of an object. from here. Okay. Here, the initial velocity of the object, that will be some value what we are going to given. For that, we can say, for numerical example, 40 meter per second. Here it is moving against the gravity. Okay, so what will happen here? It is the negative acceleration, and against the velocity of the object gradually decreases. Okay, and one point that called as dead state or a dead point. What will happen? The decreasing of velocity reaches to a value that equal to 0. Okay, that equal to 0. And hence, then it will return back to Earth. Okay. So, like if it reaches the dead state in the upward direction, when the object is thrown upwards, then its final velocity is 0. Okay, that's that we have to remember here. Then moving downwards or free fall. In free fall, if it is mentioned, the object is not going to be thrown downwards, but it is free fall. Okay, if it is free fall, then its initial velocity equal to 0. Okay, when the object moving upwards or thrown upwards with some velocity, if it reaches the dead state, the final velocity equal to 0. In the free fall condition, its initial velocity equal to 0. So these are all the keywords to be remembered while solving the numerical in the motion in straight line or otherwise motion under the influence of gravity. Okay. So it's a long video, and in this one video, I hope you all understand the lot of the contents which are related will be used in the motion in straight line. Okay. So in next video, the upcoming videos, we will discuss the solved numericals in this topic: motion under the gravity and also motion in straight line. Okay. So for more videos and the next upcoming videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Thanks for watching this video, and also subscribe for more videos. Okay. Thank you, guys.